We're learning about the determinant today. The determinant is a strange operation. Basically, it tells us a measure of a matrix. So suppose we had, we haven't been using its transformations, but suppose we had a matrix where if we multiplied something else by it, it caused a counterclockwise rotation. If it had a high measure, it would cause a large rotation. If it had a low measure, it would only cause a slight rotation. Or if we had a matrix that caused some sort of deformation, like it caused a square to be skewed if we multiplied the square by the matrix, then a high determinant would cause a large skew, and a low determinant, so anywhere between 0 and 1, would cause a slight skew to the square. Does that make sense? So we're learning an operation without the application yet. We're just basically, it's like when you're in primary school and you learn how to add and divide and multiply and subtract. You're doing that, but with matrices. All right, so the determinant, it's just a matrix operation. It can only be applied to square matrices. So if you have a rectangular matrix, can't do it. It's got to be a 2 by 2, 1 by 1, 3 by 3, 4 by 4, 5 by 5, m by m. And the output of a determinant is a scalar value, so it's just going to give you a number, just a singular number, positive or negative. Now, if we had a 2 by 2 matrix and we wanted to find the determinant, suppose we have matrix A and we want to find the determinant showed by the pipe brackets. You can rearrange your matrix such that it's got pipes instead of parentheses or brackets. So it's got the two pipes. And then the operation itself is you get the top left and multiply it with the bottom right. Subtract the bottom left multiplied by the top right. Does that seem simple? I hope so, because that's as simple as they get. So you simply multiply like that and like that. You start with this one, you multiply, then you put a subtract, and then you multiply these two, and that's your determinant. Now, they get a little bit trickier than that. You can get a 3 by 3 matrix, and suppose you want to find the determinant. It is the same as that with one additional step. What we're going to do is, firstly, at top left is over here. What I'm going to do is I'm going to cover these two up and look at what's above. It's A. Then I'm going to say times. Next thing I'm going to do is I'm going to cover up this entire row. Sorry, this entire column and this entire row. And what I'm left with is a 2 by 2. I get my 2 by 2 and I say, let's get the determinant of the 2 by 2. After my first operation, I go from being plus to quite negative. And then I cover up the second column except for the very top row. What's above my hand, Levi?
B.
B. I write B. I go times and then I say determinant of, and then I cover the middle column up and then I cover the top row. I have D, F, G, K. Why did I leave out I? It's reserved for imaginary numbers. Not that we're going to use them. Why did I leave out J?
Just because?
No, not just because. Because sometimes, rather than using I, some professions use J in place of I. So J is also reserved. Seem cool? Okay, I was positive, I became negative. What am I going to turn back into? Positive. Why? Why not? Okay, and then I cover up the third column and I get C. I multiply it by the det. And then I cover this column, I cover the top row again, D, E, G, H. Going to the next row, it's A multiplied by the determinant of EF, H, K, minus B multiplied by the determinant of D, F, G, K, plus C by the determinant of D, E, G, H. Whenever you see those two pipes, that means we're either going to go for, or it means we're going to determinant. If you want to, you can write the keyword det, so D-E-T, and then you put it in your parentheses, or you can put it in your brackets. Don't put it in the pipes, because that means double determinant. You can't do a determinant of a scalar. Does that seem cool, guys? This is more of a spec thing. This is more of a general thing. Having said that, if you did do spec, you have to do this once in the course. Possibly twice if you're doing induction, but that's not our concern. Are there any questions as to how this works? So for you guys now, it's just the pattern that we follow. All right. Simplify it. What's your favorite letter? Zoe? C or Z? Z? Capital Z. We want to find the determinant of Z. What sort of matrix do we have? Which order do we have, Mr. Jaff?
3 by 3.
3 by 3. So, firstly, starting off, let's go for the determinant. What is the first number we're going to do? -1. Multiplied by what?
Det determinant.
Yep. Determinant of?
4, -4, 0, -1.
Brilliant. I'm going to pick on Akifa. Am I going to be positive or negative?
Negative.
Negative. Then, what number am I going to pick?
Would it be positive 5 then?
It will become a positive 5 because it's going to be double negative.
Yes.
What's the matrix we now need to find the determinant of?
3, 6, -4, -1, is that it?
Excellent. Okay, finisher. Miss Porter, positive or negative?
Negative.
Gonna cover this column.
It takes 7.
I always go plus, minus, plus. Yep. Which number do I pick? 7. And then we're going to go the determinant of Little Miss Forest. What's our next matrix we need to find the determinant of? If you want, you can pick on the boys for talking.
Who wants to do it?
I'll do it.
Don't be kind, be mean.
3460.
3460.
You're welcome. I'm here for support.
Okay, and that's all the hard work done. The rest of it is just arithmetic. It's going to be -1, then 4 by -1, take 0 by -4, plus 5, 3 by -1, sorry I'm writing crooked. Did I make a mistake?
No, the definition.
No.
The matrix operation that reveals the determinant is a matrix operation that reveals the
Yeah, it's just simple grammar.
Ah, my bad, yeah.
That
You
reveals.
should know that.
You need to apologize, Levi. Okay, and then it's just calculating. So -1, -4 plus 0, plus 5, -3, plus 24.
That's not what my father said.
Okay, and we probably need a calculator for some of this. Minus
So head click. Not that hard, still. It's pretty hard.
seem okay, guys?
I think so.
Yeah.
Cool. So, effectively, let's just pretend that landed. Effectively, that's how we calculate the determinant of a 3x3 matrix and a 2x2 matrix. Using those same operations, do you reckon we could do a 4x4?
Yeah.
Yeah, you just follow the same steps. Do you see how I wrote it as finding the determinant, so you get the top left and then you go determinant? If it was a 4x4, you get the top one here, and then you get the 3x3 matrix like that. And then rather than just having 3, you'd have 4. So it's what's called a recursive operation. You just keep working your way down until it's a 2x2, where it becomes trivial. All right, now, next thing we have to do is we need to do these on the calculators, and I've just remembered I didn't get them for you.
It's not helpful.
It's okay.
You forgive me?
Yeah. Good. You're a good person. I know.
All right, I'll be right back.
You're the reason.
I was waiting for like 5 days and then
There's
it's
a
time for the
reason.
weekend.
Don't tell me I'm wrong because he told me to say that.
Hands up if you're happy and you know it, and you want a calculator.
I mean, that big cost a couple $100.
I wanted to do the right one.
Thank you. All right.
Sick of math.
Sick of all of you.
All right, ready? Okay, we got two options. We can put it in long-term memory or we can do short-term. I'm doing short-term today. We go math, vec, and we'll do a 3x3. Do we remember how to do that? Next.
Can you just press 3x3?
Yep. Next, we need -1, -5, and 7.
So you can do like 3x2 bits.
3 by 4 by.
We know that. It's like, pass it up. You get me until we finish. An abortion finish.
Okay, and there's our matrix. Now, if we want to find the determinant of this, we can go up and we can type exit, exit, options, mapvec, det.
Wow.
Isn't that so much quicker?
Maybe 59. Yeah, it's quicker.
Yeah,
Yeah.
that's a bit quicker.
Why?
But having said that, when you do your test, I'm going to give you a determinant, and I'm going to put a letter in there so you can't do that. You have to do it algebraically. Doesn't that sound really fun?
Okay, you're mad.
Can you just put like.
And there will be a part A, B, C question where that will be part A, so if you can't do part A, you won't get marks for the rest of it.
Oh, let's go.
You're even worse.
How good is that test design?
It's fun.
Pretty innovative.